Good evening, all. Let us start the first chapter of your engineering syllabus. That is, first chapter is Laplace transform. Laplace transform is used, or this concept is used in many things. So, first we can see the applications of Laplace transform. So, first application is solution of differential equation in algebraic expression. That is, the Laplace transform, this concept or the formula of Laplace transform are used to solve the differential equation, and after solving this differential equation we get the algebraic equation or algebraic expression. Second one is, it deals with the conversion of one function to another function. That is, before taking the Laplace transform of the given function, that function is in the one variable, and when we apply the Laplace transform formula or Laplace concept on this equation, we get the another function. That is, in Laplace transform we are converting one function to another function. Third one is to determine the structure of astronomical object from spectrum. That is, in astronomical object from spectrum, astronomical object means khagoliya vastu, and spectrum means it is the group of colors which we can get from passing the light through the glass or through the drop of a water. सो त्या खगोलीय वस्तू आणि त्याचं जे स्ट्रक्चर आहे ते डिटरमाइन करायला सुद्धा लॅपलास ट्रान्सफॉर्म यूज करतात. फोर्थ application is to find the moment generating function in statistics. In statistics, one concept is there, moment generating function, that is mean, variance, kurtosis. That terms we can find by using Laplace transform. The next application of Laplace transform is to solve the problem related to the network analysis, especially for electrical engineering and for civil engineering. The subject which are related to the word transform, for example Laplace transform. There are other chapters also, that is Fourier transform. Then this Laplace transform is specially useful, or this concept must be cleared for the in electrical engineers and civil engineers, because in your next year or the third year or B, you have that concept, that is Laplace transform, that is in the subject network analysis. Next application is to make the equation from vibration of springs, that is in the vibration of springs, and for that the equation of that vibration is also we can obtain by using Laplace transform. Again, next one is to solve the mixing problem involving the two tanks. That is, there are some problems related to the two tanks. In that, Laplace transform concept is used. So many of the concepts are related to this Laplace transform. So let us see the actually this chapter is unknown to you, because the concept Laplace transform is not you come across in the 12th or in first year. So let us see this Laplace transform from this its definition. So the definition of Laplace transform is, Laplace transform is indicated or it is denoted by L. Laplace means its first letter is taken here. So L of ft. Ft means the function of t. Any equation in t variable that we denoted by ft. So in t equation, here there is a equation in t, and we have to take the Laplace transform of that t equation. So what is the definition? Actually, it is a formula of the Laplace transform. So Laplace transform of function t is equal to, you can use there in many books the notations are different for Laplace transform. So some of the books mention that the Laplace transform is denoted by fs, and in some books the notation is f bar s. So you can use any equation. Any notation. So Laplace of ft equal to f bar s or fs is equal to, it is, the definition is in the form of integration from 0 to infinity e raised to minus st ft dt. So this is the definition of Laplace transform, that is the formula for Laplace transform of ft. So to find the Laplace transform of some functions, we have to remember some formula of Laplace transform, that is Laplace transform of some standard functions. So let us see this formula for Laplace transform. So Laplace transform of 1 is equal to, it is defined, that is Laplace transform of 1 is equal to 1 by s. Laplace transform e raised to at equal to 1 upon s minus a, that is if in the e raised to at means this is the exponential function, and in the power, if a is positive, then for answer of this Laplace transform, in denominator the sign is negative, that is if there is a plus a in the power, the in the answer in the denominator there is a negative sign. So Laplace transform of e raised to at is 1 upon s minus a. From this we can easily get the Laplace transform of e raised to minus at is 1 upon negative converts to positive, that is e raised to minus at Laplace is 1 upon s plus a. Then Laplace transform of sin at is equal to a upon s square plus a square. Some trigonometric functions having Laplace transform directly, we can use this formula in solving the examples. So Laplace transform of sin at is this, Laplace transform of cos at is s upon s square plus a square. Laplace transform of sin hyperbolic at is equal to a upon s square minus a square. Laplace transform of t raised to n equal to n factorial. This notation you can see this is similar to exclamatory mark, that is, but in maths this notation is for factorial. So n factorial upon s raised to n plus 1, where n is whole number, and Laplace transform of t raised to n, this has two formulae, and it depends on what is the value of n, what is the nature of n there in the example. So if n is a whole number, then we have to take the factorial formula for finding Laplace transform of t raised to n. And again Laplace transform of t raised to n is given as gamma. This notation is for gamma. So gamma n plus 1 upon s raised to n plus 1. So what is this notation? This is new to you, factorial, you know this notation, and how to solve or how to find the 2 factorial, 3 factorial. Again we can check, or we can see how to solve this factorial notation or how to solve this gamma notation in the further examples. So n factorial upon s raised to n plus 1 when n is whole number, and if n is fractional number means in the form of p by q, numerator upon denominator form. If that number in this gamma notation, that is gamma 2 by 3, gamma 4 by 3, gamma 1 by 2, gamma 3 by 2, etc. So if the n fractional number means numerator upon denominator number. If n is fractional number, then we have to compulsory use for finding this Laplace transform of t raised to n, the answer should be in gamma notation. And when n is not fractional number or whole number, we have to take the formula as in the form of factorial. So these are the formulae, we have to remember this, or because in finding the examples or solving the examples, we have to compulsory use this formulae. So these are the important formulae and basic formulae for the Laplace transform. So let us see the examples. So first is find the Laplace transform of sin 2t into cos 3t. So here we have to find the Laplace transform of trigonometric function, and here we are not given the single trigonometric function. There is a product of two trigonometric functions, that is sin into cos term, and we know for a single trigonometric function the Laplace transform is exist, or Laplace transform answer we know that we can find from this formula. But this formula is Laplace of sin a t cos a t. This formula is for single sin and cos term. But here in the example we have to find the Laplace transform of product of two trigonometric functions. So how to find this Laplace transform of product of two trigonometric functions? So here again, rest of this formula of Laplace transform, we have to recall the 12 standard trigonometric functions formulae. That is product of two functions, that is factorization, defactorization formulae we have to use here. So here for product of two trigonometric functions we have to use one formula, that is 2 sin a cos b. So if we ask in the example that is sin into cos, then we have to use the formula 2 sin into cos. Actually there are 4 formulae in a one group, that is 2 sin cos, then 2 cos sin, 2 cos cos, and 2 sin sin. These all formulae which we are studied in first year, these formulae again we have to use, or we have to recall, we have to remember in second year also. So here you have that formula list which I had given in first year. So if sin cos term is there, then we have to use the first formula from that group, that is 2 sin cos. So 2 sin a cos b, the formula is sin a plus b plus sin a minus b. So here we have to compare this LHS of this formula with your example, and by comparing we get a value. A and b are the angles, as there are trigonometric functions. So the value of a is 2t, value of b is 3t. So apply this formula to this sin 2t into cos 3t. So this is equal to, again we have to remember that this formula is for 2 sin a cos b, but in example there is no any 2 term or 2 number which multiplied to this sin cos term. So here we have to adjust that 2 number. So for that, how to adjust the number, that is we have to multiply by 2 and again dividing by 2 here. So here 1 by 2, we are adjusting 2 here because in formula there is a term, or there is a number 2 which is multiplied to sin cos term, and in example there is only sin cos term, not given the 2 number. So we have to adjust that 2 number first and then apply the formula. So 2 sin cos and adjust the number means multiply by 2 and again dividing by 2. So 1 upon 2 into 2 sin cos. 2 sin cos is sin plus sin. So sin a plus b plus sin a minus b. So a plus b means here the value of a. By comparing the LHS of formula with the given term, sin cos term, a value is 2t, b value is 3t. So in the formula, for applying this formula, in the answer there is angle is a plus b and a minus b. So a plus b means 2t plus 3t is 5t, a minus b means 2t minus 3t is minus t. So this half number is your adjusted number, Laplace of sin plus sin, that is sin 5t plus sin minus t. Half, write this half as it is Laplace of sin 5t plus sin minus t. Sin minus t means again apply the formula sin of minus theta. Sin of minus theta is minus sin theta. So write it as minus sin t and then apply the Laplace concept on this these two sin terms, that is Laplace of sin 5t minus sin t means take the Laplace separately of sin 5t and sin t. So in bracket Laplace of sin 5t minus Laplace of sin t. So half as it is Laplace of sin 5t. For finding this Laplace transform of sin 5t, we have to use this Laplace of sin 80 formula, this formula, and we have to compare. This formula is for Laplace sin 80, and we have to find for sin 5t. So here by comparing, the value of a is 5, and here a is sin 80 means here uh, we can't see any number which is multiplied to this t, that is the value of a is 1 here. So to apply this sin 80 formula to this sin 5t, so we get the formula is a upon s square plus a square, that is the number which is in numerator, and then in denominator s square plus that number square. So here a value is 5, a value is 1, and apply this formula, sin 80 formula for sin 5t as 5 upon a upon s square plus a square, that is 5 upon s square plus 5 square, that is 25, minus here a value is 1, so a upon s square plus a square gives a upon means a value is 1, so 1 upon s square plus 1 square, that is again it is 1. So here we are taken Laplace of sin 5t and Laplace of sin t by using this Laplace of sin 80 formula. Then this is your final answer, but in model answer sheet this is not given the final answer, so we have to just simplify this step to get the final answer and for getting the full marks. So here sin 5t Laplace is 5 upon s square plus 25, sin t Laplace is 1 upon s square plus 1, then taking the cross multiplication, that is 5a square plus 5 minus 1 into s square plus 25 upon s square plus 25 into s square plus 1. So this is your cross multiplication. And then by taking 4 common from this numerator and cancelling this 2, we get, take this 4 as common, so 4 into s square minus 5, and from 4 cancel this 2 from denominator, so we get 2 into s square minus 5, that is 2s square minus 10 upon this product of 2 brackets, keep it as it is. So this is your final answer. So this is your first example of Laplace transform. So first, for finding Laplace transform of product of two trigonometric functions, we have to compulsory use the factorization formulae. The one of the formula for from 4 formulae is 2 sin cos formula. If in exam we ask the terms cos sin, then use 2 cos sin formula, 2 cos A sin B formula. Then if we ask cos, that is cos 2t into cos 3t, then use 2 cos formula. If there is a term sin into sin, that is sin 2t into sin 3t term, then use 2 sin formula. So there are 4 formulae, but we need not to solve all these examples. That is for sin cos, what is the Laplace transform, then cos sin term, what is the Laplace transform, cos term, sin term. Only solve one example and remember the these 4 formulae, 2 sin cos, cos sin, cos and sin formulae. These all formulae you are listed in first year, so you can see these formulae, 4 formulae: 2 sin cos, 2 cos sin, 2 cos and 2 sin. So one example is enough for instead of solving the 4 examples. So this is your first example. Next example is find the Laplace transform of cos hyperbolic cube 2t. Here I have written these 4 formulae, that is 2 sin cos, 2 cos sin, 2 cos, 2 sin. The first angle is A and the second angle is B. A, B, A, B, A, B, A, B. And the formulae are, first formula is sin plus sin. The first angle is I have written in common, that is first angle is a plus b, second angle is a minus b. Sin minus sin, first angle is a plus b, second angle is a minus b. Cos plus cos, first angle is a plus b, second angle is a minus b. And cos minus cos, in the fourth formula the angle are, we have to write in reverse order, that is first angle is a minus b and second angle is a plus b. So using these rest of these three formulae, you can find the Laplace transform of cos sin, sin sin and cos cos terms. Next example is cos hyperbolic cube 2t, that is we have to find the Laplace transform of this. Laplace transform, this is again the notation. In exam you ask in the wording form, that is find the Laplace transform of the given function in terms of t, or in exam there is a example in the notation form, that is this is your notation of Laplace transform. So find the Laplace transform of, that is L of cos hyperbolic 2t. So here for hyperbolic function, only for single cos hyperbolic and sin hyperbolic term the Laplace transform formula is existed. For single term only, that is sin hyperbolic term, this is single term. Cos hyperbolic term, this is single term. Not for the cos hyperbolic square, sin hyperbolic square, cos hyperbolic cube and sin hyperbolic cube. These functions are, or these examples are standard examples. If you practice these first basic examples, that is Laplace transform of two trigonometric functions which are in the product form, then Laplace transform of square functions, sin square, cos square terms, for hyperbolic sin hyperbolic square, cos hyperbolic square, then Laplace transform of sin hyperbolic cube, cos hyperbolic cube. Up to these examples we have to practice, or we have to, at any cost we have to practice these examples, because there are some properties we have to study in further in this chapter. So for these properties we have to recall these examples again, these basic examples. Laplace transform of product of two trigonometric functions, then Laplace transform of square functions, sin square, cos square, sin hyperbolic square, cos hyperbolic square, Laplace transform of sin hyperbolic cube, any angle they will give in exam, and sin hyperbolic cube, cos hyperbolic cube. These examples are basic examples. If you practice these examples, then the rest of properties you can easily study. Next example is Laplace transform of cos hyperbolic 2t. So for this, here we have given not a single term, because this Laplace transform of cos hyperbolic 80. So for single cos hyperbolic term Laplace transform is exist. But for cubic terms again we have to use the formula. So which formula? So this is the basic formula, cos hyperbolic theta in the form of exponential term. So cos hyperbolic theta is e raised to theta plus e raised to minus theta upon 2. So apply this, first apply this formula for single cos hyperbolic 2t. So here cos hyperbolic 2t and its cube, it gives Laplace transform as it is. Cos hyperbolic 2t means for cos hyperbolic theta this formula. So instead of theta we have to apply this formula for 2t. So replace theta by 2t. So we get e raised to theta e raised to 2t plus e raised to minus theta plus e raised to minus 2t upon 2. And this formula is for single cos hyperbolic theta. We asked here for cubic term. So take the cube of this whole bracket. So Laplace transform of cos hyperbolic cube 2t is equal to Laplace transform of cos hyperbolic 2t. The formula we are used here. we get e raised to 2t plus e raised to minus 2t upon 2 bracket cube as it is. This cube we have to write it as it is. Then next is 1 upon 2. Next steps are some calculative steps, that is we have to take outside this 1 by 2. So there, as there is a cube, so 1 by 2 cube is 1 by 8, 2 cube is 8. Then Laplace transform of this numerator bracket and its cube. So e raised to 2t plus e raised to minus 2t, that is we have to take cube of numerator and cube of denominator separately. So this numerator cube as it is, and 2 cube is 8. So numerator cube, for having numerator cube, we have to use the cubic formula a plus b bracket cube, a cube plus 3a square b plus 3ab square plus b cube. So here first term is a, second term is b, and for applying for this equation, a term is, by comparing this formula, we get a is equal to e raised to 2t, this is your a, and plus b, this is your b. So apply a plus b bracket cube, first term is a cube, a is your e raised to t, 2t. So take its cube, so e raised to 2t, its cube. So this is your power calculation, that is rule is a raised to m raised to n. What is the formula? A raised to m, and just we have to multiply these power numbers m into n. So here we get e raised to 2 into 3, that is 60. So similarly we can apply this power formula for rest of the terms, that is a cube means e raised to 2t, that is e raised to 60, plus 3 into a square means e raised to 2t square, that is e raised to 40, into b, that is e raised to minus 2t, plus 3 as it is, a means e raised to 2t as it is, b square, that is e raised to minus 2t square, is e raised to minus 40, plus b cube means e raised to minus 2t its cube, that is e raised to minus 60. So this is the power calculation, and we are used here this power formula. A raised to mn is equal to a raised to m raised to n is equal to just multiplication of these two numbers, a raised to mn. So this is the expansion of this bracket cube by using a plus b bracket cube. Then here only remaining step is we have to take the Laplace of each term separately, that is Laplace of e raised to 60. Here we have to, there are two terms, but we can merge these two terms. For this we are using here formula a raised to m into a raised to n, that is if base is same, then we have to add these indices, that is a raised to m into a raised to n, that is base a is same. So there is a addition of powers, that is a raised to m plus n. So this is your basic formula of power. So here 4t minus 2t is e raised to 2t, then 2t minus 4t is e raised to minus 2t, and e raised to minus 60 as it is. Apply Laplace transform of e raised to 60 separately, then 3 into Laplace of e raised to 2t plus 3 into Laplace of e raised to minus 2t plus Laplace of e raised to minus 60. So here we are using only one formula, that is first formula for exponential function. What is the formula for exponential function? Laplace of e raised to it is 1 upon s minus a. If there is a negative term in power, that is Laplace of e raised to minus at, then Laplace is 1 upon s plus a. So these two formulae we have to use here. So e raised to 60 Laplace is 1 upon s minus 6, that is if Laplace of e raised to it is 1 upon s minus a, that is if in the power is positive, we have to take the negative term, and if the power is negative, e raised to minus 80, then we have to take positive term in denominator. So e raised to 60 Laplace is 1 upon s minus 6, as compare e raised to 80 with e raised to 60, the value of a is 6, and put this value of a is equal to 6 in this formula, that is 1 upon s minus 6. The value of a is 6. So e raised to 60 Laplace is 1 upon s minus 6. Then plus 3 is constant, keep it as it is. 3 into e raised to 2t Laplace is 1 upon s minus 2 plus 3 into e raised to minus 2t. There is a negative power, so we have to take positive term in the denominator. So use this second formula. So 3 as it is, e raised to minus 2t Laplace is 1 upon minus 2 converted to plus 2, that is 1 upon s plus 2 plus e raised to minus 60 Laplace is 1 upon s plus 6. So this is the Laplace transform of this each term, e raised to 60, e raised to 2t, e raised to minus 2t and e raised to minus 60. Then you can keep this term as a final answer, but you can take the cross multiplication of by taking the two terms in pair, that is first and fourth term take together and take the cross multiplication, so we get first and fourth term. This is just a calculation, or you can write this as a final answer. So first and fourth cross multiplication is 1 into s plus 6 plus 1 into s minus 6. So plus 6 and minus 6 get cancelled, and remaining terms in numerator is only one term remains, that is s and s. S plus s is 2s upon s minus 6 into s plus 6. So here for product of s minus 6 into s plus 6, we are using a minus b into a plus b formula, that is a square minus b square formula. So for this, by applying this formula, we get s square minus 36. So here this is the step s square minus 36. Then again plus the denominator terms are s minus 2, s plus 2. So take this middle two terms together and take the cross multiplication. So take 3 as common, or you can take directly the cross multiplication. So 3 into s plus 2, that is 3s plus 6 plus 3 into s minus 2 is 3s minus 3 into 2 is 6 minus 6. So this plus 6 and this minus 6 get cancelled, and remaining terms in numerator as 3s plus 3s, that is 6s upon apply a minus b a plus b formula, that is a square minus b square. So s square minus 2 square, that is s square minus 4. So take 2 as common, 2s as common, both the terms are common here. So 2s take common and cancel this 2 from this 8. The number remains as 4. In bracket we are taken 2s common, so 1 upon s square minus 36 plus, by taking 2s common, remaining term is, or remaining number is 3 upon s square minus 4. Again take the cross multiplication, 1 into s square minus 4 plus 3 into, in bracket, s square minus 36. We get this 3s square and this s square, we get 4s square, and minus 4 and this minus 3 into 36, we get minus 112 upon product of these two terms. So again take 4 common, and this numerator 4 and denominator 4 get cancelled, we get s into s square minus 28 upon the product of these two brackets. So this is the Laplace transform of cos hyperbolic cube 2t, that is if we are given here we are solved the example of hyperbolic cube for the angle 2t, and if we ask the different angle, that is 3t 4t, but there is no any change in the concept of applying the Laplace transform formula, just replace 2t by that angle, that is 3t or 4t, but the concept is same, that is to find the Laplace transform of cos hyperbolic cube angle, whatever the angle there. If we ask the cos hyperbolic cube, compulsory we have to apply this exponential formula. Cos hyperbolic theta equal to e raised to theta plus e raised to minus theta upon 2. If we ask the hyperbolic function, for that, if we have to find the Laplace transform for hyperbolic function, there is only one formula which is in the form of exponential terms. So compulsory we have to use this formula. So this is important. Again, as we solve for cos hyperbolic 2t, similarly we can solve for sin hyperbolic 2t. Just we have to remember this formula. Which formula? For cos hyperbolic theta, there is a plus sign in between these two terms in numerator, and for sin hyperbolic theta, only one slight change, that is minus sign is there in the numerator. So for cos hyperbolic theta, there is a plus sign, and for sin hyperbolic theta, there is a minus sign. So you can solve only one example for cos hyperbolic cube theta or cos hyperbolic cube 2t. Similarly, you can solve for sin hyperbolic 2t. Next example is Laplace of sin cube 2t. So this example is for hyperbolic function, and this is for regular trigonometric function, that is Laplace of sin cube 2t. Again, there is a Laplace transform formula for single sine term, not for the cubic terms. So again we have to use the 12th standard formula, that is the triple angle formula. So the triple angle formula is sin 3 theta equal to 3 sin theta minus 4 sin cube theta. But this standard formula we have to convert for sin cube theta, because we are asked here Laplace transform of sin cube term. So from triple angle formula sin 3 theta, first obtain the term sin cube theta, that is sin cube theta equal to 3 sin theta as it is, and this term we have to take in left side, and this term sin 3 theta we have to take on RHS. So plus 4 sin cube theta equal to 3 sin theta minus sin 3 theta, and we have to find the sin cube theta. So take 4 from left side to right side, that is it will go to denominator. So from this triple angle formula, find the sin cube theta term. So we get sin cube theta equal to 3 sin theta minus sin 3 theta upon 4. So apply for this sin cube 2t. So here this formula we have to apply for this sin cube 2t. So compare this left side with this sin cube 2t. So we get theta value equal to, by comparison, theta value equal to 2t. So put theta equal to 2t here. So 3 sin 2t, 3 sin 2t. Applying this formula, sin cube theta to this sin cube 2t. So 3 sin theta value is 2t. So 3 sin 2t minus sin 3 theta. Here theta value is 2t. Again we have to multiply 3 to this theta. So 3 theta equal to 3 into 2t, that is 60. So we get 3 sin 2t minus sin 3 theta, that is sin 60 upon 4. So for finding the Laplace transform of cubic equation, for hyperbolic cube equation we have to compulsory use the formula which is in the form of exponential terms for hyperbolic function, and for regular cubic function or regular trigonometric equation, cubic equation, we have to use the triple angle formula. So from triple angle formula we have to find the sin cube term, and then apply that converted formula, sin cube theta formula, to this example. So we get Laplace of sin cube 2t is, by using this formula, 3 sin 2t minus sin 60 upon 4. Then take Laplace transform of each function. So we get 3 as it is, Laplace of sin 2t minus Laplace of sin 60. That is, apply this Laplace term to this each term, 3 sin 2t and sin 60. So we get 3 into Laplace of sin 2t minus Laplace of sin 60. So 3 as it is. So what is the formula for, we can use for finding Laplace of sin 2t? So there is a Laplace of sin 80. So Laplace of sine, for single sine term, Laplace transform formula is there, a upon s square plus s square. So sin at Laplace is a upon s square plus s square. So sin 2t Laplace is 2 upon s square plus 2 square. That is, here a value is 2t. So we have to compare this sin at with this sin 2t. So here a value is 2, and after comparison of sin 60 with sin 80, we get a value is 6. So apply this formula a upon s square plus s square as a upon, that is 2 upon, a upon means here 6 upon, s square plus s square, that is square plus 2 square 4, s square plus 6 square, that is s square plus 36. So sin 2t Laplace is a upon s square plus s square, that is 2 upon s square plus 2 square, and sin 60 Laplace is a upon s square plus s square. Formula is this, 6 upon s square plus 6 square, 36. Then then final calculation is take 3 as common or 6 as common, and from this, and by simplifying, take common number is 6. So take 6 as common, and by simplifying, 6 by 4 is 3 by 2. Then in the remaining terms in the bracket as 1 upon s square plus 4 minus 1 upon s square plus 36. Taking cross multiplication, we get 32 upon the bracket multiplication. So this is your Laplace transform. Thank you.